In our last lesson, we took a look at writing neutral ionic compounds. Ionic compounds are always neutral, and this determines the number of ions that I'm going to have. Now, in this lesson, we're actually going to do the opposite. We're going to start with the ionic compound, and we're going to backtrack to figure out what the charge on the cation is. We are going to figure out the charge on the cation specifically because we always know the charge on the anion from the periodic table. But remember, in the D block of the periodic table, we can't predict the charge on the cation. So sometimes it's necessary to backtrack to what that charge is. And we're going to learn just how to do that in this lesson. All right, let's say we have iron with 2 oxygens, like we just said. Here's the steps. First, we're going to write the charge on our anion. Okay, so oxygen, if I look at the periodic table, I know that it's 2 minus. And further, I know that I have 2 of these. How do I know I have 2 of these? Well, there's a 2 right there. So that 2 is telling me there's 2 oxygens. And then I'm going to add up the negative charge. 2 and 2 gives me a minus 4. Okay, now over in this column in the orange, I'm going to put the positive charge. So here we're putting our positive stuff, and here we're putting our negative stuff. And now I'm going to write how many irons I have. I just have 1. And the whole goal is to get the charge on an individual iron. Now I know these 2 down here have to match. So where I have negative 4 here, I have plus 4 here. So they match with the sign change. And now I distribute that plus 4 across how many irons I have. So if I had more than 1 iron, it would get distributed across the more than 1 iron. In this case, I just have 1. So that means my 1 iron must give a plus 4. So that must be the charge on my iron. If I was writing the name of this compound, that would mean that plus 4 would tell me that I would write Roman numerals of 4, which you'll get to in a future video if you don't know it now. All right, let's do another one. Here I have manganese, 2 of them, with 3 sulfurs. So once again, I'm going to write all my sulfurs on the right. Sulfur, sulfur, sulfur. And I'm going to write all my manganeses on the left. Manganese, manganese. And remember, the goal is to get those question marks. Sulfur I can get from the periodic table. I know it's minus 2, minus 2, minus 2. When I add up the charges on the anions, I'm going to get a minus 6. That matches the total positive charge on the left, gives me a plus 6. Now I distribute. So if I have 2 things that add up to plus 6, what must that be? Well, basically I'm dividing 6 by 2, right? So I get plus 3 on each of them. And so that's the answer. And again, if I was naming, that plus 3 would tell me that I should put a Roman numeral of 3 into my name for this compound. All right, one more. Let's do FeCl3. Let's once again write my 3 chlorines. I have 3 because there's a 3 right there. And I have just 1 iron. All right, writing the charge on my chlorines, I have minus 1, and minus 1. Those add up to minus 3. I know that has to match over here, which gives me the plus 3. And when I distribute that across just the 1 iron, I get plus 3. Again, that tells me that I would use a Roman numerals of 3 if I were writing the name of this compound. Okay, so that's a quick and easy way to go from the charge on your anion to the charge on your cation. Thanks for watching this episode of Real Chemistry.
Hey, hey.